Today's notes are going to be on Module 3, Section 6, Proving Angle Relationships. A lot of the notes here are not new, but I am going to encourage you to still get them down as they're going to be important for proofs moving forward as well. And so the first one, this is an old, but now it's official postulate. All right, angle addition postulate. And so the whole angle here, angle ABC, can be broken up to the two smaller angles added together. So angle ABD plus angle DBC equals the whole thing, angle ABC. Just like we talked about the other day with segment addition, two parts make a whole. We have the same thing here with angle addition, two parts make a whole. So the small angle plus the other small angle makes the entire larger big angle. And so you're going to have problems like this in your homework tonight. What is the measure of angle 3? Angle 3 is this little angle down here. If angle 1 is 23 and the whole thing, ABC, is 131. Also, in angle 2, please note that box. That little box there means it's a right angle, which means it's 90 degrees. So if I just write in here some of the things I know it says angle 1, which goes right in here, is 23 degrees. Right? I know this is 90 degrees. I know the entire thing is 131 degrees. And so first I'm going to do, what is 90 plus 23? It is 113. So the whole thing, 131 minus the 113 I already can account for, leaves 18 degrees left. Right? And so the measure of angle 3 is 18 degrees because they all must add up to 131. Next, we have linear pair theorem. Again, we've had linear pair theorem, so this is not new for us. Angle 1 plus angle 2 makes 180 because they make a straight line. So the two angles form a line, and they equal 180, or they are supplementary. We're going to have two in a row here that are very, very similar. Right? And they're just both plays on transitive property. If angles 1 and 2, all right, are supplementary, and angles 3 and 2 are supplementary. So I know 1, whatever it is, plus 2, whatever it is, makes 180. 3, whatever it is, and 2, whatever it still is, makes 180. Then 1 and 3 have to be the same. Let's use some numbers here just to show this. If this is 120, then this is 60. All right, because these two have to make 180. Well, if these two have to make 180, what does this one have to be? 180 minus 60 is 120. So this one down here would have to be 120. So if 2 doesn't change and they're both supplements, then these two have to be the same to make 180. And so if two angles are supplementary to the same angle, they're congruent. If two angles, so that would be the whole proof here, or the congruent, the definition. If two angles are supplementary to the same angle, then they are congruent. And then we have the same thing here. If two angles are complementary, right, to the same angle, then they are congruent. And here the example would be, that if 4 and 5, when you combine them, they make 90. And then when you combine 6 to that same 5 and they make 90, then whatever, because 5 is not changing, so whatever 4 is and whatever 6 is the same. And then the next theorem is also not new. Vertical angles. You please know what angles are vertical. Angles across from each other. So 1 and 3 are vertical, or 2 and 4 are vertical, and vertical angles are congruent. And then these are all our right angles, ones we've had so far. All right, it's important to know all right angles are 90. Right? If it's perpendicular, that means it's a right angle or right angles. Right? If there's a linear pair of angles, then one of them is 90, the other one is also 90. Right? If two angles are congruent and supplementary, then each angle is 90. This one is new, but that should make logical sense to you. If two angles are the same and they add up to 180, then each one has to be 90. If two angles are the same and they equal 180, they have to be 90 each, because the only way to make two angles make 180 is if they're both 90. Next example here, and this is going to be one you're going to have this kind of problem in your homework. Find the measure of angle 4 if 5 is 2x and 4 is x plus 9. What kind of angles are 4 and 5? Are they vertical? Nope. Are they a linear pair? Yes, they make a straight line. And so you're going to say if 4 is 2x and 5 was 2x and 4 is x plus 9, that combined they make 180. And so you have 2x plus 1x makes 3x, still plus 9, still equals 180. You then minus 9 to both sides. And then you're going to divide 3 with the next step. And so you get x equals 57. Now you want to find the measure of angle 4. The measure of angle 4 equaled x plus 9. And you're going to plug that 57 in. And so the measure of angle 4 equaled 66 degrees. We're only going to have one proof in the homework tonight, so let's take a reminder. Look here at a proof. Here they have the given. Angle 1 is congruent to angle 2. Proof angle 3 is congruent to angle 4. And so we start every proof with the given. Now this one doesn't have a given that really helps us, except for we're going to use it for transitive property. I do see, though, in the picture, vertical angles. And so I know 1 is congruent to 3 and 2 is congruent to 4. And these are our choices down here because of vertical angle theorem. And then all they did is take this angle 1 is congruent to angle 3 and flip it around. Again, I don't think that's super important, but the book is going to use that. And so that is symmetric property. So I use this one. Now, what was the point of flipping it around so that it would hopefully make sense to you? If 1 is the same as 2 and 3 is the same as 1, or I should probably say this way, is 3 is the same as 1 and 1 is the same as 2, then 3 is the same as 2. And so that is right here, and that's what we're going to put down. Angle 3 is congruent to angle 2, and then it's transitive property. Okay. And then if 3 is the same as 2 and 2 is the same as 4, all right, then 3 is the same as 4. And again, that's transitive property. For either one of the places that they put transitive, if your brain said substitution instead, that would be just as good. So we use those 4 in our proof. All right, that is the assignment. I wish you nothing but the best and good luck.